Hi, this is Mrs. Kidman, and in this video, we're going to be discussing the remainder theorem. So the remainder theorem says that if a polynomial is divided by a binomial in the form of x minus k or x plus k, then the remainder is going to be whatever that k is put back into our function. So this is a really cool thing because we can kind of check to see whether or not our remainder is correct by plugging it back in when we do that synthetic division. And so the remainder theorem is a really cool pattern that we can see, knowing that if I put this value in, this is the number I'm going to get back out. So let's take a look at kind of what this remainder theorem says. So we want to use synthetic division to evaluate what happens when x equals -4. So we can evaluate it two ways. We can either do f of -4 and plug -4 in. Minus -4 squared plus 13 times -4 plus 29. Now, I don't know about you, but that seems a little bit overwhelming and like a lot of work. So instead, what we're going to do is we're actually going to use synthetic division to evaluate what x minus 4 is going to be. Because by that remainder theorem, it says if I do synthetic division where I put -4 in my box up here, then whatever I get for my remainder is going to be what this equals. So let's take a look and see what happens. So let's write out all of our coefficients here. So I've got a 5, -1, 13, and 29. And then we are going to add those, and in this box here should be our solution. So we've got a 5. -4 times 5 is -20. Ooh. And that gives us a -21. -4 times -21 is going to give us an 84. And 13 plus 84 will give us a 97. Now, -4 times 97 is going to give us a -388. So then as we add those, 29 minus 388 is going to give us -359. Okay, there's our solution there when we do that synthetic division. Now let's check to see what happens when we do it by plugging it into our function and see what happens. So first we've got that -4 cubed times 5, and this piece here gives us a -320. Minus -4 squared, which is 16. So -320 minus 16, -4 times 13 is -52. And then plus 29. Now, if we add all those numbers together, -320 minus 16 minus 52 plus 29 equals -359. Look, we have the same answer for both. Now, this is not the wrong way to do it. But notice how this computationally was a little bit easier, setting up that synthetic division, adding numbers instead of having to do those multiplies by exponents, especially because sometimes we don't know what those big numbers are. And so it really can come into play there when we have a simple calculator or a simple calculation to use that remainder theorem to figure out what that's going to be. So let's go over one more example or two more examples where we use this synthetic division to figure out what happens when I put x equals 5 in. So let's go ahead and do it with this one. So we've got 5. Our coefficients are -4, 10, and -21. We're going to bring this one down, and we're adding. Here will be our answer. 5 times 4 is 20. -10 plus 20 is 10. 5 times 10 is 50. And -21 plus 50 gives us 29. So now we can check this one rather quickly. So f of 5 equals 4 times 5 squared minus 10 times 5 minus 21. Well, 4 times 5 squared is 100 minus 50 minus 21, and that equals 29. So again, either way works, but that synthetic division is so much easier instead of having to multiply all those numbers out. Okay, let's do this one last time where we just do that synthetic division. So we have a 2 here. We are going to write out our coefficients. So 5, 2, don't forget our 0 for the x squared, -20, -6. Our remainder or our answer is going to be right here. We're going to drop down our first one. 2 times 5 is 10. This becomes 12. 2 times 12 is 24. 0 plus 24 is 24. 2 times 24 is 48. -20 plus 48 is going to be 28. And 2 times 28 is going to give us 56. Minus 6 equals 50. And so this right here is what would happen if we evaluated it. Isn't that so awesome that that remainder theorem works that way? So that is how we can use the remainder theorem in conjunction with synthetic division to evaluate an x value of a polynomial. Now note that these x values are very specific. These x values that we're evaluating here only work when it's a factor of that number. So we can't just choose any willy-nilly x value. Well, we can, and that remainder will give us what we have. But it's super cool that we can use this synthetic division to do it. If you have any questions, feel free to reach out. If you get a remainder of 0, then that means that that number is actually a factor or a 0 of our polynomial function there. But it is a super cool way that we can figure out what that evaluation is. So if you have any questions, feel free to reach out. But that is how I can use the remainder theorem in conjunction with synthetic division to evaluate values in a polynomial function.